Good evening, and welcome to Late Night Science, where we drift through the quiet spaces between wonder and sleep. Tonight we return to the beginning, to a time before time began to shine. We thank those who already travel with us through these slow galaxies of thought, and if you're new here, we invite you to settle in, to join us in this shared quiet. As you listen, perhaps let us know, where in the world are you hearing this from? Somewhere under your own patch of sky. If you find calm here, let it reach you softly, and remember to linger with us again next time as we follow the universe back into its dreams. Now, let's begin. Some things in the universe do not start with fire. They begin with silence. The kind of silence that feels alive, dense, heavy, ancient. Before the first stars awakened, before light itself was born, there was only a vast ocean of darkness. Cold clouds drifted through it, faint and endless, like breath lingering in the cold. This was the universe, only a few 100 million years old, still young, still cooling from the great expansion that had flung everything outward. We call this period the cosmic dark ages, a time when hydrogen and helium floated freely, atoms unbroken but unseen. There were no stars yet to light them, no galaxies to gather them. The universe was transparent, but there was nothing bright enough to see. It was like standing in a vast mist, knowing it exists only by the faint pull of gravity, by the promise that something would one day glow. The matter around us, hydrogen, helium, traces of lithium, filled everything evenly, quietly. Yet even silence is never perfect. Tiny ripples existed, remnants of the first fluctuations born in the early universe when quantum uncertainty left fingerprints on space itself. Those ripples became seeds of structure, invisible scaffolds where gravity would begin its patient work, and so gravity waited. It gathered gently, molecule by molecule, dust upon dust. There was no rush. In the cold, particles moved slowly, colliding less, clinging more. Over millions of years, regions slightly denser than their surroundings began to pull more matter inward. Small clouds turned into larger ones, immense, diffuse nebulae stretching for light years across. We call them molecular clouds now, but back then they were the universe's first quiet attempts at form. Inside these vast veils of hydrogen, the faintest pressures began to build. Gas drawn inward, compressed, and with compression came warmth. Not the kind we feel on our skin, but the kind that stirs within atoms, the vibration of possibility. Slowly, imperceptibly, darkness began to prepare for its own undoing. If we could drift there now, through that ancient void, we'd see nothing. But we would feel the weight of becoming. Every atom a promise. Every drift of gas a thought forming in the universe's mind. It is here that light was first imagined. And yet this was not an act of sudden birth. It was a long meditation, gravity breathing in slowly, carefully. As each region collapsed, it drew more gas inward, forming dense knots within the cloud. These knots spun gently at first, then faster as they shrank. Rotation became their balance, their resistance against falling entirely inward. The early universe was not uniform. Some regions rich in matter grew large enough to collapse into entire galaxies, the first faint islands of structure. Within them, smaller clouds formed the first stars. But before that, for countless generations of silence, space remained dim. It was the waiting room of light. Science tells us that the first stars, called population 3 stars, were giants, hundreds of times the mass of our Sun, composed only of hydrogen and helium. They formed quickly, burned fiercely, and died young. But before they existed, before their light cut through the cosmic fog, there was only the breath before fire. The nebulae gathering their quiet strength. Imagine standing in that stillness. There is no color, no sound, only the faint whisper of hydrogen atoms meeting. Each collision releases a sigh too soft to hear, a fraction of heat that will one day ignite creation. The darkness does not resist. It waits, as if listening for the right chord. And perhaps that is what gravity is in the universe's ear, pressed against its own silence, listening for the moment when stillness turns to song. In time, the pressure deepens. Density builds at the centers of clouds where temperatures rise, where atoms move faster, closer, harder. A core forms, invisible yet inevitable. The nebula breathes in one last time, pulling its edges inward. The stage is set, and then, almost imperceptibly, the first light appears. Not yet brilliant, not yet steady, a shimmer at the center of collapse. This is the prelude to starlight, heat from compression, radiation from falling matter, flickers of warmth whispering through dust. The dark is not gone, but it begins to soften. These are not explosions, they are awakenings. Every star that will ever exist begins this way, a long, slow inhalation, a gathering of patience, an acceptance of inevitability. The nebula surrenders to its own gravity, and in that surrender, creation begins. When we study this era, we see beauty in numbers, temperatures of a few tens of Kelvin, densities barely measurable, timescales spanning millions of years. But within those numbers lies the story of everything that would come. Galaxies, planets, oceans, breath. Every atom in our bodies was once part of a silence like this, waiting for its turn to shine. The first stars broke the quiet. Their light, scattered across space, rionizing the hydrogen fog, ending the dark ages. But before that radiance, before that cosmic dawn, there was this. The breath before light, the perfect pause of potential. We often think of beginnings as loud, as sudden, as violent. But most beginnings are slow. The universe began not with a shout, but with a whisper. It is in that whisper that we find comfort. The knowing that even creation takes its time. So, as you rest tonight, imagine those early clouds drifting across an invisible sky. They move without hurry, without fear of never arriving. They trust in gravity, in time, in the quiet certainty that warmth will come. And maybe that is what the universe dreams before it shines. Not of light itself, but of readiness. The awareness that everything bright must first be still, that even the stars must learn how to wait. Soft hum fades, replaced by distant echoes, as if the cosmos itself is breathing out. We'll drift deeper next time into the heart of these clouds to watch gravity shape the first sparks of fusion. Until then, may your thoughts be light, your mind at rest, and your breath steady, like the universe before it began to glow. There are places in the universe where everything we have ever been still lingers, not as memory, but as matter. Every nebula, every drifting cloud of dust is a quiet archive of creation and destruction. Tonight, as we drift once more through the silence, we begin to understand that what we call dust is not mere debris, not emptiness, not waste. It is history, ancient, recycled, patient beyond measure. The universe never truly discards what it makes. It lets it rest, lets it drift, and when the time comes, it breathes it into new form. The nebulae we see glowing faintly through our telescopes, the Orion, the Eagle, the Carina, are not first creations. They are second breaths. They are built from the ashes of stars that once burned with impossible light, stars that lived full, violent lives before collapsing back into silence. Hydrogen and helium still form the bulk of their being, but scattered through them like punctuation in a cosmic sentence lie traces of carbon, oxygen, silicon, iron, the heavier elements forged in stellar hearts and released in their final size. Every grain of cosmic dust carries the fingerprint of a star that once was. Every particle weaves the memory of a death into the possibility of another beginning. When a massive star dies, it dies spectacularly. In a moment we call a supernova, the star's outer layers are hurled outward, traveling at thousands of kilometers per second. The explosion sends shockwaves rippling through space, stirring the calm hydrogen seas nearby, enriching them with metals, the astronomer's term for every element heavier than helium. The universe, still young in its cycles, learns through this violence how to make complexity. These shockwaves, carrying the ghosts of stars, become the sculptors of new nebulae. They sweep through interstellar clouds, compressing them, igniting new waves of collapse, new cradles for the next generation of stars, and so dust becomes destiny. What once glowed becomes what will glow again. Between these events for millions of years, the matter simply drifts. Tiny grains of silicate, carbon, and ice wander through space, cold and unhurried. Light from distant stars strikes them, scattering into color, and from that scattering we see the faint glow of the nebula. It is not self-illumination, but reflection, the afterglow of lives long gone, mirrored across uncountable particles. To see a nebula, then, is to look directly into a memory. The light we admire is second-hand, yet more beautiful for having lived twice. Our instruments capture these clouds in stunning color, but their real hues lie far beyond human sight. The reds of hydrogen alpha emissions, the greens of doubly ionized oxygen, the deep blues of scattered starlight. Together they compose a spectral language. When decoded, this light tells us what the nebula is made of, how hot it is, how old it might be. In those numbers, scientists hear echoes of the long story of stellar evolution, the fusion of lighter elements into heavier ones, the dispersal of those elements into space, and the eventual reassembly into something new. Each chemical signature is a ghostly voice, whispering of the star that made it. If we could hold a grain of that cosmic dust between our fingers, impossible, fragile thing, it would feel like nothing. Its weight is less than a whisper, its scale almost beyond imagination. Yet within that dust lies the calcium that will one day form bones, the carbon that will shape life, the iron that will carry oxygen through blood. It carries not just atoms, but potential. And in that potential lies a message that nothing in the universe is truly lost. When astronomers peer into the remnants of ancient supernovae, such as the Crab Nebula or Cassiopeia A, they see filaments of gas expanding through space, intricate and delicate as the veins of a leaf. The debris is moving outward, but within it new dust is forming. Even as the explosion fades, creation has already begun again. It is a cycle so vast that it feels sacred, stars dying to make the ingredients for worlds, worlds forming to give birth to beings who can finally look back and notice. We are, in every measurable way, the consciousness of dust remembering itself. Hydrogen, the simplest and most abundant element, still dominates these clouds, and it remains the essential ingredient for the next generation of stars. But hydrogen alone cannot explain the richness of the universe. For that we need the heavier elements, those made in the furnaces of previous lives. When we say that we are made of star stuff, it is not poetry. It is chemistry, patient and precise. The oxygen in every breath we take was once trapped in a collapsing core. The carbon that shapes our cells was born in the delicate balance of nuclear fusion. The iron in our blood was cast into being by the death throes of a giant. And still, between all these details, there remains a kind of silence, a silence that science can describe but never fully explain.
Why should matter remember?
Why should the ashes of destruction know how to gather again? Gravity provides the how, but not the why. Perhaps, in some quiet way, the universe itself hungers for continuity. Not life, not consciousness, but presence. A nebula drifting in the dark is the cosmos's way of ensuring that nothing ever truly disappears. In these clouds, temperatures are astonishingly low, sometimes just a few degrees above absolute zero. Yet in this cold, chemical miracles unfold. Simple molecules form, hydrogen molecules, carbon monoxide, ammonia, water ice. They cling to dust grains, building complexity molecule by molecule. These are the early steps toward life, carried out in silence, in darkness, without audience or intent. It reminds us that creation does not need observation to be real. It happens quietly everywhere all the time, and somewhere in those depths. Light from a distant star finds a path through the dust, scattering, bending, shimmering, as if the universe were holding up a mirror to its own past. We watch, and in watching, we join the story. The nebula, billions of years old, continues its patient work. Dust gathers, gas cools, gravity waits, and we, suspended between awe and belonging, realize that we are made of the same patience. Perhaps that is the most humbling truth of all, that every breath we take recycles the atoms of forgotten suns, that the universe has lived within us far longer than we have lived within it. Each nebula we see is a reminder that creation does not begin with perfection, but with remnants, with fragments, with ghosts. So when we look upon those drifting clouds of color and light, we are not looking at something other than ourselves. We are looking at our own ancestry, at the dust that once burned, fell silent, and will rise again. Every speck of that dust has lived more lives than we can imagine, and still it drifts on, waiting for the next call of gravity, the next quiet invitation to become something new. Long pause, ambient hum softens. The nebula breathes, and so do we. In its stillness, we hear our own beginnings. And perhaps, in that shared silence between dust and dream, we finally understand that even the ghosts of stars never truly die. Between the stars lies a silence so deep it almost feels alive. There are no winds here, no sound, no movement that can be seen, only the faint shimmer of particles adrift in the dark. It is in this stillness that the universe prepares its next act. What seems like nothing is never truly empty. The space between stars, though called a vacuum, holds atoms and dust scattered thinly across unthinkable distances. They drift for millions of years, sometimes for billions, carried by the quiet tides of the galaxy. And yet, even here, gravity is listening, is patient, tireless, eternal. It waits for the faintest imbalance, a slightly denser region, a ripple of passing energy, and then, slowly, it begins to pull. The dance of creation begins not with motion, but with stillness. In that stillness, hydrogen atoms, and the lightest and simplest of all things, start to drift closer together. They move not because they choose to, but because gravity will not let them remain apart. It is an invisible tenderness, a force that binds not through violence, but through inevitability. Across vast regions of interstellar clouds, this gathering begins imperceptibly. A single cubic meter of gas might contain only a few hundred atoms, fewer than the air in a sealed room by a factor of trillions. Yet over regions spanning light years, that whisper of matter adds up. Slowly, inexorably, mass gathers. The weight of the cloud increases, and with it, the pull strengthens. This is how gravity builds its cathedral. Not in haste, but in patience. The calm of interstellar space conceals an immense tension, a kind of suspended potential. Every drifting particle carries within it the memory of what it could become. The dust, made of ancient starlight, begins to spiral inward. Tiny collisions exchange energy, slowing motion, bringing particles ever closer. The stillness thickens. What was once almost nothing becomes something more, a condensation of time, of matter, of destiny. The gas cools, radiating away its faint warmth into the infinite night, allowing the collapse to continue. Each step is measured in thousands of years, each movement in fractions of light years, and yet, over cosmic time, gravity never falters. If we could stand within such a forming cloud, obviously impossible though it is, we would see nothing but darkness. The density, though growing, is still too low to scatter light. Yet we would feel the subtle pressure, the soft tug toward the center, the infinitesimal sense that every atom has chosen a direction. The cloud begins to rotate, ever so slightly. A single spark of angular momentum, inherited from the galaxy's motion, prevents a perfect collapse. Instead, it spreads the material into a slow, turning spiral. The center tightens, growing heavier and warmer. Around it, layers of gas continue to drift inward, feeding the growing core. Stillness, once passive, becomes weight, and in that weight lies promise. The deeper the collapse, the greater the pressure. Temperatures rise, density climbs, and the whispers of gravity grow louder. The atoms, so used to drifting free, now find themselves pressed into intimacy. Every collision transfers energy, every vibration builds heat. The cloud begins to glow faintly in the infrared, invisible to our eyes but radiant with quiet purpose. What began as nothing more than a gentle pull has become a cosmic inevitability, the prelude to a star. Gravity has no malice, no intention. It does not seek beauty, yet it creates it endlessly. It gathers chaos into structure, silence into sound, emptiness into light. The weight of stillness is not oppression, but transformation. Within these collapsing clouds, there is both destruction and creation. Turbulence that tears apart filaments even as others form. Pockets of gas collapse while others disperse. Some regions will never become stars, others will birth entire systems. Yet all are guided by the same invisible hand, the same patience that has governed the universe. Since its first breath, when astronomers observe star-forming regions like the pillars of creation or the Horsehead Nebula, they are witnessing this process mid-sentence. Each pillar, each wisp of dust marks a boundary between what is collapsing and what remains still. Inside those dark cocoons, young stars are beginning to form, hidden from sight by the very material that made them. They will not emerge for millions of years until their light becomes strong enough to carve through the dust that birthed them. Until then, gravity holds its secret close. And perhaps that is what makes this phase of cosmic evolution so haunting, the tension between stillness and becoming. We are watching the universe hold its breath. Every particle is waiting, balancing between motion and rest, potential and realization. It is a kind of universal meditation, a slow gathering of purpose that defies our human sense of time. The weight of stillness becomes a language in itself, one spoken not through words, but through the pull of matter upon matter. If we could translate that language, we might hear something like this: wait, gather, become. The atoms have no awareness, yet their behavior feels almost deliberate. They surrender to gravity not as victims, but as participants in a story larger than themselves. In that surrender, they find meaning, or rather, they become the foundation of meaning itself. For every planet, every life, every thought that will one day emerge depends on this quiet, unseen gathering. Without gravity's patience, there would be no light, no chemistry, no consciousness to witness it. We often think of creation as a moment, a sudden spark, a flash, an act of will. But here, In the weight of stillness, we learn a gentler truth. That creation can also be slow, unseen, inevitable. The universe does not hurry because it does not need to. It understands that even the faintest pull, given enough time, can shape galaxies. The calm between stars is not emptiness. It is incubation. Every atom drifting there is on its way to becoming part of something greater, though it may take 100 million years to arrive. As the central regions of the collapsing cloud grow denser, pressure pushes back against gravity's pull. There comes a moment, far in the future, when the balance will hold, when the collapse will stop, and fusion will begin.
That moment will mark the birth of a star.
But for now, in this chapter of silence, the universe remains suspended in waiting. Gravity continues its patient work, sculpting the invisible, writing the next story in the language of wait and stillness, and we, observing from our tiny corner of one such star's creation, find ourselves reflected in that patience. Our thoughts, our breaths, our own small gravities, all echo this ancient rhythm. We too are pulled toward one another by invisible forces. We too are shaped by quiet pressures, unseen yet unyielding. The stillness between stars is the same stillness we find in ourselves when we listen long enough. So the question lingers, vast and tender. What invisible patience binds the universe together? Perhaps it is not a force outside of us at all, but something that lives within. A memory of the same gravity that once gathered the dust that became our bones, our hearts, our stars. In the end, the weight of stillness is not a burden. It is the universe remembering how to hold itself, softly, until it is ready to shine. In the quiet depths of a dark nebula, gravity begins to sing. Not in notes we can hear, but in movements we can feel. The long, slow cadence of matter falling toward itself. Each particle responds to the pull of another, tracing invisible lines through the dark, and together they begin to hum a pattern older than light. The rhythm is delicate, almost imperceptible. It moves through the silence not as a sound, but as a memory of sound, a vibration of inevitability that shapes the universe in silence. Everywhere within the cloud, the same law holds true. Where there is mass, there is attraction. Regions that are slightly denser become slightly louder in this silent song, drawing nearby gas inward. Hydrogen gathers hydrogen, dust gathers dust. The space between them collapses like a deep breath being taken by the universe itself. We might imagine it as a kind of symphony, but this is not a melody with a beginning or end. It is a continuous hum, a gravitational chant, a cosmic lullaby repeating across billions of years. The song begins in whispers. Tiny clumps form, then draw in more matter, their voices strengthening as they grow heavier. In the still cold of interstellar space, the tempo is impossibly slow. A single rotation of a collapsing cloud might take hundreds of thousands of years. Yet to the universe, this is rhythm, the patient heartbeat of creation. Nothing here hurries, nothing breaks the flow. Even chaos itself, turbulence and shock, becomes part of the harmony. Gravity takes what is uneven and turns it into motion, shaping disorder into pattern, soundless yet full of music. If we could translate this gravitational song into human hearing, it might sound like a low, endless hum, a tone too deep to be played by any instrument, resonating not through air, but through the very fabric of space-time. Einstein's equations tell us that mass bends space and that bend travels as waves, faint ripples moving outward at the speed of light. In the birth of a star, these ripples are tiny, too small to ever reach our instruments. But they exist, the faintest echoes of creation, like the first murmur before a note is sung. The universe has always been a composer of silence. It works not through noise but through weight, not through motion but through patience. Each fragment of dust that falls inward becomes a note in gravity's score. The more matter gathers, the stronger the resonance becomes. At the center of the collapsing cloud, pressure builds. Temperatures rise. The song deepens, shifting to lower tones. The cloud no longer drifts, it turns. Rotation begins to define it. Around the forming core, a disk of gas spreads outward, thin and luminous in infrared light. The outer regions fall more slowly, the inner regions spin faster, and so the rhythm evolves, the slow turning waltz of matter in love with its own fall. And yet even here there is balance. For every pull inward, there is motion outward, the ancient duet between gravity and angular momentum. This balance gives the system grace. Without it, the cloud would collapse completely, losing all form. With it, the collapse becomes ordered, circular, poised. It is this tension, this equilibrium between falling and spinning that creates beauty. Stars are born from balance as much as from pressure. Gravity provides the melody, but motion gives it harmony. Over time, the core grows hotter, denser, more radiant within its shroud of darkness. The song intensifies, no longer faint and formless, but deep and resonant, vibrating through the surrounding gas. It is not yet light, but it is the promise of light, the build-up before the first note breaks through. Around it, the disk ripples with density waves, spiraling patterns that one day may become planets. Even in this early stage, gravity's rhythm writes futures into the dust. Everything that will ever orbit here already listens to the music of its origin. When we look at distant star-forming regions through the eyes of our telescopes, we see this song frozen in motion, luminous clouds, pillars of gas, glowing filaments that twist like smoke. We are looking at harmonies that have been playing for millions of years, their frequencies carved into shape by gravity alone. There are no conductors, no instruments, no audience, and yet the performance continues, vast and perfect in its silence. And perhaps what draws us to these images, these veils of dust illuminated by young stars, is not just their beauty, but their familiarity. Somewhere deep inside us we recognize the pattern. The same gravity that shapes the nebula shape the atoms in our bodies. The same forces that turn gas into stars once turned stardust into us. We are, in a sense, the lingering echo of that original song. Fragments of the chorus,
vibrating still. So when we close our eyes and imagine the universe at work,
we might listen not for sound, but for feeling. The slow inward pull of time and matter, the patient rhythm of existence. Gravity's song is not something we hear. It is something we are. It holds galaxies together, binds moons to planets, draws oceans toward the moon, and keeps our feet pressed gently to the ground. It is the lullaby that never ends, the quiet hum that began before light and will linger long after light fades. If gravity were a voice, it would not shout. It would whisper, low and endless. A melody of belonging that threads through every atom, every orbit, every breath. We do not just live under its influence, we live inside its song. The same stillness that once drew dust toward the heart of a nebula now draws us toward one another, toward meaning, toward the quiet recognition that everything in the cosmos moves together in the same invisible rhythm. And so we listen, not with our ears, but with our being. We listen to the stillness that holds the stars in place, to the silence that vibrates beneath everything we know. Gravity's song does not ask to be heard. It simply is all, a soft, eternal hymn that reminds us in every moment of falling and every moment of rest that we are all part of the same slow dance. Inside the dark and deepening heart of a collapsing nebula, a quiet transformation begins. The dust that once drifted without purpose now moves with growing urgency, pulled inward by gravity's patient hand. Each atom, once cold and distant, now collides with others in a slow, invisible storm. The cloud thickens, folds upon itself, and what was once emptiness begins to tremble with motion. In these collisions, energy finds its first voice, faint, scattered, but rising. This is how heat is born, not in flame, but in the ceaseless meeting of dust and gas, in the crowded silence of matter learning how to move. The process is almost invisible. There is no spark, no sudden ignition, no bright flare to mark the moment when motion turns into warmth. It happens gradually, gently, or like breath, finding rhythm after a long sleep. Each collision transfers a little energy, and the cloud's core begins to glow in wavelengths our eyes cannot see. Infrared light slips softly through the dust, a secret shimmer in the darkness. This is the first heartbeat of a star, pulsing faintly beneath layers of shadow. At these early stages, temperatures climb from the chill of deep space, just a few degrees above absolute zero, to thousands of degrees within the growing core. But even now the light remains hidden. The outer layers of the nebula absorb and scatter every photon, wrapping the embryo of a star in a cocoon of darkness. If we could drift inside, we would see nothing but mist and motion. And yet, in the center, something profound is taking shape. The simple conversion of falling into heat, of gravity into glow. This transformation is one of the universe's quiet miracles. Gravity, which pulls inward, becomes energy that pushes outward. Motion becomes resistance, resistance becomes temperature. The very act of collapsing creates the strength to resist collapse. It is a paradox made stable by balance, a reminder that even in the most profound stillness, the seeds of motion wait. Every rise in pressure, every spark of warmth is gravity's way of holding the system together. Without it, there would be no stars, no light, no us. The young protostar, still hidden, begins to spin faster as the cloud contracts. Its rotation shapes the surrounding disk into delicate spirals, channels through which matter continues to flow inward. As particles fall, they accelerate, striking the core with greater energy, feeding the warmth within. The deeper the collapse, the greater the heat. At around 10,000 degrees, hydrogen atoms move so quickly that their collisions strip away electrons, forming plasma, the state of matter that defines stars. Yet even here, fusion has not begun. This heat is mechanical, born of motion, not of nuclear fire. It is the warmth before the flame, the prelude before ignition, and as it gathers, something subtle changes. The random collisions begin to organize. Pressure and temperature form gradients, layers that define the young star's future structure. Convection begins. Currents of gas rising and falling within the core, like slow tides beneath the surface of a deep ocean. Each movement redistributes energy, spreading warmth evenly through the sphere. The entire cloud becomes a living system, a vast, breathing organism powered by the memory of its fall. If we were to listen closely, not with ears, but with imagination, we might hear the faint murmur of atoms meeting, separating, meeting again.
Millions of tiny impacts every second, each one a whisper of energy shared.
This is not fire as we know it. It has no flame, no light, no smoke. It is a warmth that exists in pure potential, contained within darkness. A kind of embryonic energy waiting to be born into radiance. Astronomers observe this stage through long wavelength eyes, telescopes tuned to infrared light that pierces the dust. They see clouds that appear cold to visible sight, yet glow with hidden heat. The data shows slow rotation, dense cores, and faint radiance from within. Each of these is a cradle, nurturing a star still in its quiet phase. The universe hides its beginnings well. It prefers silence to spectacle. Creation here is not an explosion, but a gathering of warmth in the dark, and yet there is beauty in this restraint. We often associate heat with passion, with burning, with immediacy, but the universe teaches otherwise. Heat can also be patient, soft, and formative. It can accumulate slowly, shaping order from chaos. It can grow unseen, feeding on the quiet work of gravity. The warmth that now fills the core is not destruction, but preparation. The steady deepening of energy until the moment is right. In time, pressure and temperature will rise high enough for hydrogen nuclei to fuse.
Only then will the true light appear.
But for now, the universe waits content with this gentle beginning. This stage, this long gathering of invisible fire, lasts for millions of years. To human minds, that is eternity. To the cosmos, it is a heartbeat. The star-to-be turns within its cradle, its interior growing hotter, denser, more radiant with every century. Around it, the remaining disk of gas and dust begins to cool, preparing to give birth to planets. The system breathes, inward, outward, as it balances collapse and heat, gravity and light, stillness and motion. We can imagine this process mirrored within ourselves. The warmth of life, the spark of thought, the quiet gathering of energy before expression. These are echoes of the same cosmic rhythm. Before every beginning there is stillness. Before every light there is heat that cannot yet be seen. The universe creates not in haste, but in patience. It gathers, builds, and then, when the balance is perfect, it ignites. So we return to the question, can warmth exist before flame, and life before form? The answer glows softly in the heart of every star, in the warmth of every living being, in the quiet between every breath. Heat is not born of fire. It is the memory of motion, the promise of creation. And somewhere, deep within the darkness, the first light waits. Patient, forming, listening to the universe breathe. In the quiet center of the nebula, a new form takes shape. It is small compared to the cloud that cradles it, yet immense by any human measure, a sphere of gas so dense and bright that it begins to define itself against the dark. We call it a protostar, but names are small things for such beginnings. It is not yet a star, not yet luminous enough to shine freely, but it is alive in motion and heat, a gathering of everything the universe has whispered into form. Around it, the vast cocoon of dust turns slowly, a veil that both conceals and protects the fragile light within. The protostar trembles in balance. Gravity pulls inward, relentless and firm, while rising pressure pushes outward, desperate to escape. Between those forces, an agreement is struck, not permanent, but sufficient. The sphere quivers with energy, rotating on its axis, flattening ever so slightly as centrifugal motion shapes its edges. Jets of material begin to shoot from its poles, twin streams of plasma that carve narrow paths through the surrounding dust. These outflows are the protostar's first cry, its way of announcing presence to the void. Through them, angular momentum is shed, allowing the core to grow more compact, more stable, more defined. If we could see it, we would not see light in the colors of our eyes. Instead, we would perceive warmth as shadowed brilliance, infrared glow pushing faintly through veils of gas. The cocoon is thick, scattering and absorbing visible light, so that even telescopes must look through other wavelengths to find it. Within that secrecy, the protostar thrives. It feeds upon the surrounding disk, drawing gas inward along magnetic fields, each fall of matter releasing energy that deepens the inner fire. The accretion disk itself gleams faintly, illuminated from within by friction and heat, spiraling closer, feeding the child at its center. And yet it is not a peaceful process. The environment is turbulent, sculpted by competing flows and shocks. Streams of gas collide, magnetic lines twist and realign, and radiation begins to push outward. The protostar is caught between nurturing and eroding forces, but this tension is what allows it to grow. The universe has always created through contrast, stillness and motion, confinement and expansion, darkness and light. Without the shelter of shadows, the heat would dissipate. Without the pressure of collapse, no fusion would ever begin. Every beginning, it seems, requires both tenderness and struggle. Over time, the balance shifts. The protostar continues to accrete mass, and with each new layer, the core temperature climbs.
Millions of degrees now, the density rising until atoms are pressed so closely that their individual boundaries begin to blur.
The collisions are fierce, the pressure immense, yet still no fusion, not yet. The threshold is near, but the universe waits. Around the central sphere, the outer disk evolves. Dust grains stick together, forming clusters that will one day become planets, moons, and asteroids. The scene is both chaotic and serene. A cosmic nursery wrapped in silence, where gravity is the midwife and time is the lullaby. Inside the protostar, energy moves outward through convection. Hot material rises, cools, and sinks again, carrying heat through vast cellular motions. The surface flickers with faint turbulence, shimmering invisibly through the dark shroud. Every motion, every vibration, every exchange of heat is part of the long, slow rhythm of formation. The sphere breathes, not in air, but in motion, expanding slightly as heat rises, contracting again when the balance shifts. It is not alive, and yet it behaves with the grace of something becoming alive. Astronomers studying this stage often describe it as the most secretive phase of star formation. Protostars are hidden from ordinary sight, detectable only through the long eyes of infrared and radio telescopes. In those wavelengths, they appear as glowing knots within dark clouds surrounded by jets and arcs of emission. Observing them is like listening through walls. We cannot see the child, but we can hear the heartbeat. Each flicker of light, each change in spectral line tells us how the protostar gathers strength. Through these signals, we glimpse our own origins, for our sun once lived inside such a cocoon, learning how to shine. There is a lesson in that hidden glow. Every birth, cosmic or human, requires darkness, a place where form can gather without interruption, where warmth can accumulate before the world intrudes. The universe seems to understand this intuitively. It does not rush its beginnings. It folds them into secrecy, allowing potential to unfold at its own pace. The protostar's cocoon is not a prison but a womb. Within it, gravity writes the laws of structure, heat sketches the outlines of future light, and silence holds everything in place. Eventually, the cocoon will thin. Radiation will pierce through, clearing the surrounding dust. The jets will widen, carving out open channels in space. The protostar will become visible, luminous, confident in its own fusion. But for now, it remains sheltered, a flicker wrapped in patience. The outer disk continues to rotate, the future solar system already taking shape in slow, invisible revolutions. Each orbit, each grain of dust, each swirl of gas contributes to a grand choreography whose final form we can only imagine. So we ask, does every beginning require the shelter of shadows? Perhaps it does. Shadows give shape to light. Stillness gives meaning to motion. Even the brightest stars were once hidden, learning their warmth in silence before revealing themselves to the cosmos.
And in that there is comfort.
The universe does not hurry what it loves. It lets it grow, unseen, until it is ready to shine. And somewhere, in that distant darkness, a new star turns softly in its sleep. The child of the void, dreaming of the light it will one day become. In the silence of the forming system, gravity composes a slow and patient melody. Around the brightening protostar, the remaining gas and dust no longer fall directly inward. They begin to settle into orbit, guided by invisible rules written in the curvature of space. What was once a cloud becomes a plane, a vast, rotating sheet of matter, glowing faintly from friction and scattered light. This is the protoplanetary disk, a circle of possibility, a cradle of future worlds. Rotation, once gentle, now defines everything. As the gas collapses, conservation of angular momentum ensures that what falls inward must also spin faster. Like a dancer pulling in her arms, the nebula tightens its motion, trading space for speed. The more it contracts, the faster it turns. The process is ancient and universal. The same physics that forms galaxies and hurricanes, stars and atoms. In this turning, chaos finds order. Turbulent clouds align into rhythm. Gravity's music becomes visible. The disk shines in reflected light. Dust grains catch the faint glow of the protostar, scattering it outward in golden halos. Up close, it would not be silent, soundless perhaps, but alive with motion. Currents of gas spiral inward, dragging microscopic particles with them. Collisions are constant but gentle. Grains stick together, growing from motes to pebbles, from pebbles to boulders. It is a slow choreography of contact, a ballet of adhesion. Every collision changes the future, every orbit a chance for creation. Within the inner regions where temperatures soar, volatile elements evaporate, leaving behind rock and metal. Further out, the cold preserves ice and gas, allowing larger bodies to form. The disk becomes a gradient of chemistry, an architecture of temperature and distance that decides the destiny of worlds. Here, terrestrial planets will rise from dust and stone. Farther away, gas giants will gather their enormous atmospheres. Even at the edges, beyond the faintest glow, comets will sleep in frozen silence, keeping the early whispers of the solar system preserved in their cores. Astronomers, observing young stars in distant nebulae, can see these disks directly. Some are thousands of years old,
Others millions.
In visible light, they appear as soft halos, but in infrared and radio images they blaze with structure. Rings, gaps, and spirals trace the invisible hand of forming planets. Worlds that are still gathering, unseen, yet already reshaping their home. Each gap in the dust marks a place where a planet-to-be clears its orbit, sweeping debris aside. The universe, in its quiet way, is sculpting futures one rotation at a time. The forces at play are both simple and immense. Gravity gathers,
Motion balances.
friction dissipates. Every atom negotiates between falling and flying, between surrender and escape. The result is stability born from motion, an equilibrium of constant change. The disk, though luminous, is not eternal. Over time it will thin. Gas will drift inward or be blown away by the growing star's radiation. Dust will either fall into the star or bind itself into planets. But for now, it glows like a halo of becoming, a cosmic wheel of dust and desire. If we could drift within it, the view would be breathtaking. The protostar would blaze at the center, hidden behind veils of light and dust, its glow refracted into endless golds and reds. Around it, the plane of the disk would stretch for billions of kilometers, dense with swirling clouds, twisting vortices, and delicate filaments. The smallest particles would shimmer like embers. The largest rocks would drift in slow spirals, silent yet full of purpose. The airless expanse would hum with motion, every orbit echoing the rhythm of gravity's will. The process is not peaceful, though it appears serene from afar. Magnetic fields thread through the disk, channeling flows of charged particles.
Shocks ripple through gas lanes, redistributing momentum.
Collisions reshape or destroy what they create. The path from dust to planet is not a straight line, but a long sequence of trials. And yet the outcome is always the same. Persistence wins. Where there is gravity, there will be gathering. Where there is motion, there will be form. Scientists estimate that such disks can last from 1 to 10 million years, a brief moment in cosmic time. But within that window, everything happens. The chemistry of life, the architecture of orbits, the inheritance of stars, all are written here in the faint turning of dust around light. Every world that will ever be born must first belong to a disk like this one. Every ocean, every mountain, every moonlit night begins as a whisper of motion in a circle of gas. And so we look at these young systems light years away, and see echoes of our own beginning. The disk that once surrounded the newborn sun has long vanished, but its children remain, Earth among them. Our oceans were stirred from its vapor, our metals forged in its dust. Even the air we breathe began as gases swirling through that ancient ring. We are made of its remnants, shaped by its rhythm, bound to its turning. The nebula, once a shapeless cloud, is now an orchestra. Gravity conducts, motion plays. Every particle contributes to the harmony of creation. The disk sings a song of becoming, soft, constant, infinite in its patience. From its swirling motion, stars will glow brighter, and worlds will rise, each one carrying a memory of this gentle revolution. So we ask, how many worlds wait inside a single whirl of dust? Perhaps countless. Perhaps only the ones that survive long enough to remember their beginning. But if the universe has taught us anything, it is that even the smallest motion repeated with devotion can give rise to something enduring, light, world, or life itself. And so the disk turns endlessly, a circle of dust around a spark of hope where gravity dreams and creation waits its turn. Deep within the collapsing heart of the nebula, the darkness begins to tremble. Pressure, built through millions of years of slow contraction, now weighs upon itself with unimaginable force. Atoms that once drifted freely in the cold void are pressed so closely together that their boundaries blur. Hydrogen, the simplest element, the firstborn of the universe, feels the growing ache of proximity. The core is no longer silent. It hums with anticipation, as if the cosmos itself is holding its breath, waiting for the inevitable to unfold. For so long, everything has been motion without light, collisions without fire. But in this moment, something irreversible begins. The core, now reaching 10 million degrees, crosses a sacred threshold. The invisible becomes luminous. Hydrogen nuclei, stripped of their electrons, move with such velocity that repulsion can no longer keep them apart. They merge, fusing into helium. In that instant, a fragment of mass vanishes, reborn as energy. Einstein's quiet equation whispers itself into existence: E equals mc squared. This is not an explosion. It is a surrender. The hydrogen does not resist. It transforms. Bound by the strong nuclear force, protons find each other in the chaos and create something new. The fusion of 4 hydrogen atoms yields 1 helium nucleus. And the difference, the missing mass, becomes light. The protostar, once hidden and trembling, ignites from within. The pressure of gravity that once crushed now meets the equal and opposite push of radiation. In that balance, a star is born. At the surface, the glow pushes outward through layers of gas, scattering photons in endless ricochet. It will take tens of thousands of years for each particle of light to reach the surface, but once it does, it escapes freely, a first breath released into space. The cocoon of dust that once concealed the star now shimmers with reflected brilliance. What was once darkness now carries the faintest trace of dawn. The nebula, long dormant, becomes luminous with memory. Every star in the night sky has passed through this moment, this quiet threshold between collapse and creation. No two are the same, yet all share this fundamental transformation: gravity's hunger turned into radiance. The violence of pressure becomes the gentleness of warmth. Light, the universe's oldest language, begins again. From one side of the galaxy to the other, the same process unfolds in countless hidden nurseries, clouds of gas igniting in slow succession, like candles catching fire in a cathedral of time. The mathematics of it are precise, almost austere. The balance between gravity and radiation defines the life of the star. Too much pressure and collapse resumes, too little, and the fire fades. But within that balance lies beauty. Each photon released carries the story of atomic unity. of matter remembering its origin. The energy will travel for billions of years across the vacuum through the dust, through the eyes of future beings who will look up and call it starlight. The fusion process is astonishingly efficient. For every second that passes, our sun converts roughly 4 million tons of matter into pure energy, yet it barely notices the loss. Its lifetime stretches across billions of years. The light that warms our oceans, that stirs our weather, that fuels every leaf and heartbeat, all traces back to this same moment of becoming, hydrogen, uniting under pressure, remembering the warmth of the early universe. Scientists can trace this birth through spectral lines, through the shifting colors of starlight. Young stars, like the one forming now, emit more in the infrared, still veiled by dust and gas. As they mature, their light sharpens, piercing through the remains of the nebula. The surrounding clouds glow in response, illuminated from within. To the observer, it appears as a cosmic bloom, a region once cold and lifeless, now pulsing with color. The transformation is not only physical, it is poetic. The universe, once dark, now paints itself in light. And still we ask, what does this mean beyond the numbers? Beyond fusion and gravity and thermodynamics? Perhaps it means that creation is not an act of sudden invention but of remembering. That light is simply the universe recalling what it once was. Hydrogen, born in the Big Bang, has always carried within it the potential for radiance. It only needed the right stillness, the right weight, the right time. Within the new star's core, the process stabilizes. Fusion now runs as a steady pulse, converting matter to light in an endless rhythm. The star's surface settles into gentle equilibrium. The surrounding dust, warmed by radiation, begins to thin. Winds from the young star push outward, carving space within the nebula. The cocoon unravels, revealing a glowing orb suspended in the darkness. The first sun of a new system. Its light travels outward, reaching the edges of the disk where frozen worlds and drifting rocks absorb their first dawn. The nebula, once defined by shadows, now carries illumination in its heart. The transformation is complete, from stillness to fire, from collapse to creation, from silence to song. And yet the process continues imperceptibly, endlessly. The star will burn for eons, consuming hydrogen in quiet devotion, holding gravity at bay with the pressure of its light. Its surface will shimmer, its heart will pulse, and around it planets will slowly gather and awaken. To those who look upon it from afar, it will seem eternal, a steady point of brilliance in the night. But in truth, this light is fragile, finite. Every beginning carries its own end, written not in despair, but in balance. For now, though, the star lives, radiant, new, and full of promise. The nebula exhales, the darkness softens, and the universe glows a little brighter. Creation, it seems, is not a single moment, but a remembering, a return to warmth, to connection, to light. Every photon released carries within it a whisper of that first ignition. And perhaps, somewhere deep in that brightness, the universe itself smiles. Not for what has begun, but for what it has finally remembered. In the vast stillness of space, the first stars begin to breathe light into their surroundings. What was once a soft veil of gas and dust now shimmers with radiant scars, towering shapes sculpted by light itself. These are the pillars born not from stone but from resistance, carved by the newborn suns that dwell within. Their names echo through our observations: the Eagle, the Orion, the Carina. Each one a cathedral of vapor and time, where creation and destruction entwine in luminous equilibrium. We gaze upon them through telescopes, peering across thousands of light years, seeing what no eye was ever meant to see directly. The process of becoming, preserved in light that began its journey long before we existed. What we witness is not chaos, though it may appear so. It is the dialogue between pressure and illumination. The radiation from young, massive stars pushes outward, eroding the surrounding clouds. Yet the dust, dense and reluctant, resists. And in that resistance beauty forms. Every ripple, every curling plume of mist is shaped by invisible forces. Ionized hydrogen glows with soft crimson light, while cooler dust remains shadowed, sculpted into columns that reach like ancient fingers toward the radiance. Gravity clings to the densest regions, protecting them from the onslaught of energy. Inside those dense pockets, new stars are already forming, small and silent, hidden within cocoons that tremble in the glow of their elders. Thus, even as light tears the nebula apart, it also gives birth to more light. Destruction feeds creation. Erosion seeds renewal. In the Eagle Nebula's famous pillars of creation, each structure stands several light years tall, immense clouds of hydrogen and dust, slowly evaporating under the fierce starlight nearby. The edges glow faintly, heated and stripped by ultraviolet radiation. Beneath that brilliance lies tenderness, young stars stirring within the very tips of the columns, gathering matter from the same material that is being burned away. The universe seems to hold both gestures at once, the caress and the fracture, the gift and the taking. To us, these scenes appear frozen, timeless, yet in truth, they are moments caught in an endless flow. The light that reaches us now left thousands of years ago. What we see may already have changed or even vanished. The pillars might have eroded further, or new stars might have torn through their walls entirely. But the image remains, a kind of memory etched across space-time, a photograph of the universe mid-breath. Light, in its quiet persistence, reveals what shadow conceals. It sculpts form by opposition, tracing the boundaries where matter resists its touch. Without that resistance, there would be no shape, no texture, no contrast. The same is true perhaps of us. We are formed not only by what shines through us, but by what holds firm, what endures the radiance and remains whole. The pillars remind us that creation does not always mean comfort. It can be a process of exposure, of being stripped bare until only essence remains. The interplay between radiation and gravity continues, shaping the nebula into ever finer patterns. As ultraviolet light strikes hydrogen, electrons are displaced, then recaptured, releasing photons in a steady glow. This is the science of beauty. Atoms responding to energy with quiet inevitability, turning destruction into color. What we perceive as majesty is the mathematics of ionization, repeated countless times per second across light years of distance. Yet even in understanding, the wonder does not fade. If anything, knowledge deepens it, revealing the tenderness hidden inside the equations. In the Orion Nebula, just visible to the naked eye from Earth, a cluster of young stars known as the trapezium illuminates a vast cloud of gas. The light from these stars radiates outward, creating a cavity of brightness. Around the edges, dense knots of gas form globules, embryonic stars still gathering mass. The glow, the shadows, the curling tendrils of dust, all are the language of formation, written in the dialect of light and resistance. When we study these regions, we often call them stellar nurseries, but perhaps that term is too gentle. They are more like foundries, places where matter is tested by fire, where dust becomes the foundation for worlds. In every direction, the story repeats. Radiation pressures dust, dust shields new stars, and from that balance, life eventually arises. Without destruction, there would be no clearing for new creation. Without light's pressure, the nebula would remain still and silent forever. We tend to think of light as purely benevolent, but in truth it is both creator and destroyer. It liberates, but it also consumes. It reveals, but it also erases. The The pillars exist precisely because light cannot pass through them completely. The universe, it seems, finds its beauty in these boundaries, in the places where something says no, not yet, not entirely, and in that defiance, structure is born. As we observe these magnificent shapes rendered in false color by our instruments, we realize that their hues are not merely aesthetic. Each wavelength carries information: red from hydrogen, green from oxygen, blue from sulfur. Together they compose a silent spectrum, a visual symphony of chemistry and time. It is as if the universe paints portraits of its own transformation, using elements forged in ancient stars as pigments, and perhaps that is what moves us most, the realization that everything we see in these cosmic sculptures, every glowing edge, every dark filament, is temporary. The pillars will crumble, the stars will scatter, the dust will drift again. But in their brief existence, they embody the entire paradox of creation, that to shine is also to fade, that to give birth is also to let go. So we watch across the gulf of light years, and we listen in our own way. The pillars stand like verses in a poem too vast to recite in full, each one a reminder that the universe creates through opposition, through the friction of forces that seem incompatible, yet are forever entwined. Light continues to shape the dust, and dust continues to shape the light. Neither wins, neither loses. Together, they compose the quiet rhythm of existence, a cycle without malice or mercy,
Only motion and memory, and somewhere within that interplay,
we glimpse ourselves, beings carved by time, illuminated by experience, still standing in the soft tension between what burns and what endures. Perhaps that is what the pillars truly teach, that destruction and creation are not opposites at all, but two notes of the same cosmic song. In the beginning there was darkness, not the absence of light, but the waiting for it. And when the first stars ignited, their light did not arrive all at once. It unfolded like a spectrum whispered into being. Through the veils of nebulae that light met gas and dust, scattering, bending and blooming into color. Each hue, each faint shimmer, became a note in the symphony of creation. The universe, silent for eons, began to speak in light. We see these colors now through the lens of time. Reds and blues and greens stretched across the sky like ancient verses. To our eyes they are beauty. To physics they are memory. Hydrogen glows in soft crimson tones, oxygen shines pale green, helium breathes blue. Together they weave the palette of existence, a living spectrum born from the simplest elements. Each wavelength carries the signature of a process, a birth, a death, a transformation. The cosmos paints with what remains, and every color is an act of remembrance. When starlight travels through a nebula, it is not just light moving through space. It is energy conversing with matter. Photons collide with atoms, lifting their electrons to higher states. When those electrons fall back, they release light, precise in color, a perfect fingerprint of the atom's identity. The universe does not waste meaning. Every hue is deliberate, every tone exact. To gaze at a nebula is to read the story of energy itself, written not in words, but in wavelength. Hydrogen, the most abundant element, offers the dominant red, the H-alpha line.
long and soft, glowing in nearly every nebula we know. Oxygen, rarer but no less eloquent, adds its cool green, a breath of life in the cosmic mist.
Helium and sulfur give blue and violet touches, faint but pure, like the echo of starlight in deep water. Together they create the subtle gradients we see in the great images of space, those dreamlike vistas captured by telescopes orbiting above Earth. Yet these images, magnificent as they are not what the human eye would truly see. The colors are translated, mapped by scientists to reveal invisible truths. Some wavelengths lie far beyond human vision. in infrared or ultraviolet realms. By shifting them into visible form, astronomers allow us to witness what would otherwise remain hidden. The result is not illusion, but interpretation, an artistic truth born from data. We are seeing through translation, through the careful compassion of science. Still, even when we know the method, the beauty endures. A nebula's palette is not random. It follows the chemistry of creation, hydrogen tracing the memory of stars, oxygen marking the scars of their death, carbon and sulfur whispering the potential for life yet to come. In every tone, a chronology unfolds. The red of persistence, the green of renewal, the blue of possibility. The universe is not painting for us. It is recording itself, documenting the balance between fire and stillness. And so, when we look at the colors of the Orion Nebula, for instance, that soft, rose-tinted bloom punctuated by streaks of emerald and sapphire, we are not simply witnessing beauty. We are seeing the afterglow of nuclear reactions, the transformation of matter into energy. Each particle of light began its journey deep within a star, traveling unimaginable distances to find our eyes. By the time it reaches us, it has become ancient, older than the Earth, yet still capable of stirring emotion. There is something profoundly human in this. The idea that color itself carries memory. When a photon leaves a star, it holds the record of its birthplace, temperature, density, elemental composition. It travels through the emptiness, untouched by time, until it is absorbed, reflected, or seen. When it meets us, its journey ends, but its story continues. The red we perceive is not just red, it is history preserved in vibration. The universe, through color, keeps its diary open for anyone patient enough to look. Our perception of color is not universal. It is biological. Human eyes evolved to see the narrow band of light between infrared and ultraviolet, a sliver of the cosmic spectrum. Within that narrowness, though, we perceive infinite variety. The same hydrogen line that burns red to us might be invisible to another creature, or seen as sound by an instrument. The universe does not care how we perceive it. It only offers what it has. Yet somehow, in this limited perception, we find meaning enough to call it beautiful. When the Hubble and James Webb telescopes reveal images of nebulae, they are showing us time in translation. Infrared data becomes soft gold.
Ultraviolet becomes azure.
These are colors not of the eye but of understanding. Representations that make the invisible visible. Science, in its quiet way, is a bridge between reality and perception. Through its lens, we are allowed to see what once only gods could imagine. And yet, beyond the data and the wavelength, lies something older than knowledge. The simple human reaction to color. It soothes, it stirs, it lingers. Perhaps this, too, is part of the cosmic design, that we respond emotionally to the same energy that shaped us. The reds that calm us are the hydrogen that built our stars. The blues that ease our thoughts come from the oxygen that fills our lungs. The universe, it seems, has been speaking in color long before we learned to see it. To study a nebula's light is to listen to its language. Each spectrum line is a word, each combination a phrase, each gradient a memory of fusion and decay. The cosmos speaks in this tongue fluently, endlessly. Stars write it in their deaths, dust repeats it in reflection. Planets inherit it in silence. We, made of those same atoms, are fluent without knowing it. When we stare at a photograph of a nebula, what moves us is recognition. The quiet, subconscious realization that we are reading our own origin. The colors of creation are not merely beautiful, they are precise, sacred, and patient. They remind us that everything in the universe glows not because it chooses to, but because it must. Energy seeks expression.
Matter seeks release.
And light simply remembers. So when we see the reds and greens and blues of the heavens, let us not ask only what they are made of, but what they mean. They are not decoration. They are evidence, the cosmic fingerprint of becoming, the silent record of transformation repeated across eternity. And perhaps if we listen closely enough, we might hear what color is truly saying, that everything that ever was still speaks softly through the light that remains. In the quiet after creation, the newborn stars begin to breathe. Their breath is not air, but energy. Streams of charged particles rushing outward at unimaginable speeds. Stellar winds, invisible yet relentless, sweep through the nebula that once cradled them. Radiation follows, warm and unforgiving, carrying the light of their birth across the darkness. What was once a gentle cloud of gas now trembles under the touch of its own children. The story of a nebula does not end with the birth of its stars. It begins again in their response. The very forces that shape them now turn outward, sculpting the remnants of the cloud that gave them form. Ultraviolet light floods the dust, ionizing hydrogen, breaking apart molecules, reshaping the landscape. Winds carve cavities and corridors, like rivers etching stone. The nebula's soft architecture begins to shift. Rounded edges dissolve into tendrils, sheets of gas curl into arcs and waves. The act of creation becomes the art of transformation. To the eye, it is a spectacle of motion frozen in stillness. The Trifid Nebula, for instance, displays this dialogue vividly. Dark lanes of dust cutting through a pink sea of hydrogen light. Those dark paths are scars. Regions where stellar winds and radiation have torn through denser pockets of matter. Yet paradoxically, they also shelter new beginnings. Within those shadowed spaces, gravity gathers again, forming new stars in the very material that was once stripped away. The universe wastes nothing. It recycles beauty into more beauty, death into more life. This duality, destruction, giving way to creation, defines the cosmic sculptors. Radiation burns and winds disperse, but in doing so, they reveal. The glowing edges of the Horsehead Nebula, for instance, shine precisely because they are being eroded. What appears solid and eternal is in truth transient, a fleeting sculpture formed by the hands of energy and time. The universe carves with light, and its sculptures are made of impermanence. We often think of wind as chaos, but in space it is a kind of artistry. Every gust from a young star carries the imprint of its energy, its magnetic field, its temperament. These winds collide with the surrounding gas, compressing some regions and scattering others. Over millions of years, they create intricate shapes, filaments, bubbles, pillars, each one unique, each one a record of the star's presence. Radiation pressure adds another layer, pushing outward, balancing gravity's inward pull. Between these two forces, structure arises by not planned, not random, but emergent, inevitable. In the Rosette Nebula, this dance becomes almost tangible. At its center, a cluster of massive stars emits torrents of radiation, their winds blowing a hollow cavity into the surrounding gas. The edges glow bright, where the energy meets resistance. The result is a cosmic rose, delicate yet vast, petals sculpted by light, framed by shadow. What we see is not a static form, but a living process, an endless reshaping. Every ray of light, every gust of stellar wind is a chiseled stroke in the sculpture of time. On Earth, wind erodes mountains and shapes dunes.
In space, it crafts nebulae.
The scales differ, but the principle is the same. Energy transforms matter, form yields to flow. Perhaps this is a lesson the universe repeats in every medium, that beauty is not the result of perfection, but of interaction. The things we create inevitably change us, just as stars alter the clouds that bore them. Creation, it seems, is never one-sided. The science of these processes is exact, yet poetic in its inevitability. Stellar winds are made of high-energy particles, protons, electrons, helium nuclei, ejected from the star's surface at thousands of kilometers per second. Radiation pressure acts in tandem, as photons transfer momentum to matter, pushing dust away. Over time, these combined forces clear out cavities and form what astronomers call H2 regions, zones of ionized hydrogen that glow with soft, reddish light. Inside these glowing shells, the density drops, allowing more light to escape. The nebula becomes porous, transparent, and a revelation in every sense of the word. In these transformations, we glimpse something deeply human. We too are sculptors of our surroundings, shaped in turn by what we make. Our creations, art, cities, technology, relationships, exert their own kind of wind upon us, shifting our form, altering our path. We build and are built. The stars remind us that creation is not control, it is conversation. The nebula's beauty lies not in resisting change, but in surrendering to it gracefully. There is a moment in every nebula's life when the winds grow strong enough to tear it apart entirely. The cloud disperses, its gas scattered across the void, its dust absorbed into the interstellar medium. To us, this seems like loss, the death of something luminous. But to the universe, it is continuity. Those scattered elements will drift until gravity gathers them again, somewhere new, into another nebula, another generation of stars. The sculpture dissolves, but its material endures. Form fades, purpose persists. When we look at these cosmic structures through our telescopes, we are seeing not only the results of physical forces, but also the essence of relationship. Radiation shapes matter, matter shapes light, and both together shape us, as observers, as participants in the same story. The photons that illuminate a nebula's edges may travel for thousands of years before reaching our eyes, carrying with them the memory of that interaction. To witness them is to share in the ongoing act of creation, to feel, however faintly, the wind that once moved through stars. Perhaps that is why these images move us so deeply. Beneath the science lies recognition that transformation requires surrender, that to give energy is to lose form, that change is not the opposite of existence, but its fulfillment. The nebula knows this instinctively.
It does not fight the wind or flee the light.
It simply allows itself to be reshaped, trusting that every motion, every loss, is a continuation of what began long before. So when we watch the sculptors at work, the winds, the radiation, the patient physics of becoming, we might feel the same truth stirring quietly within us. We too are shaped by what we release, carved by the energy we offer to the world, and perhaps, in the end, the question is not what we create, but how we are changed by the act of creation itself. The stars, after all, seem to whisper the same answer. Everything that shines must first learn to let go. In time, every nebula must fade. Its once luminous body, shaped by gravity and fire, begins to thin and scatter into the galactic wind. The same radiation that once carved its edges now disperses its heart. What was once a cathedral of light and dust and a nursery of stars all grows transparent. Its tendrils dissolve into the quiet dark between constellations, and the vast sculpture that once defined the heavens becomes invisible. The cloud dies, but what it leaves behind still glows. Within that emptiness, the children of the nebula continue to burn, bright, steady, alive. Each star carries in its core the chemistry of its birth, hydrogen forged from the ancient gas, traces of carbon and oxygen left by stars that lived before. The nebula's memory is not lost. It is transmuted into light. Every photon that escapes a star's surface carries the signature of its ancestry. Wavelengths shaped by the elements that once drifted through a cloud's silent arms. When we gaze at the night sky, we are not just seeing stars. We are seeing echoes, the soft persistence of matter through time. The dying clouds have given their essence to the living, and in turn, those stars will someday return that gift to the galaxy. It is a cycle so vast and gentle that even eternity seems too short to measure it. A nebula's death is not sudden. It is a long, graceful exhalation. Stellar winds grow stronger, radiation pressure mounts, and the cloud's material thins, releasing one veil after another. What remains is faint, like breath on glass, visible only through the most patient instruments or through the imagination of those who know what once was. Astronomers call these remnants diffuse nebulae, ghosts of the cosmic womb. But even as they fade, their influence endures in every direction. In the Orion Nebula, for instance, the stars that now shimmer brightly at its center were once hidden, wrapped in shadow.
Over millions of years, they burned away their cocoon, revealing themselves and scattering the gas that had shaped them.
One day that glowing expanse will be gone, dispersed so thinly that no human eye, no telescope, will detect its presence. But the stars it bore will remain, crossing the galaxy as luminous wanderers, carrying the story of their origin in silence. There is something deeply human about this fading, the quiet truth that even as our beginnings dissolve, what they gave rise to continues. We are built on the same principle. The atoms in our blood, our bones, our breath, all of them were forged in stars that once were, and before that, in nebulae that vanished long ago. Our existence is the echo of clouds that no longer shine. In us, the dying nebulae live on. Science describes this continuity in precise terms: conservation of matter, transformation of energy. But within those laws lies poetry. No atom is lost.
It only changes home.
The hydrogen that once drifted in the Eagle Nebula may now be burning in a distant star's heart or floating in the atmosphere of an exoplanet. The dust of one dying cloud may someday rest on the surface of another world, beneath the feet of beings yet unimagined. The cosmos is not wasteful. It is recursive, a perpetual act of reuse and renewal. As the nebula dissolves, its stars begin to shape new destinies. Their gravity stirs the interstellar medium. Their light ignites nearby clouds. Their explosions, when their time comes, will seed the next generation of nebulae. The death of one cloud becomes the birth of countless others. Every fading veil, every drifting grain of dust is an investment in future creation. The galaxy, it seems, believes in inheritance. To the human eye, a nebula's disappearance might seem tragic, like watching a familiar landscape vanish into fog. But to the universe, it is simply change, inevitable, necessary, sacred. In its dispersal, the nebula fulfills its purpose. It was never meant to last forever. It was meant to give. Its fading is not a failure, but a fulfillment, the transformation of potential into presence. We might think of the stars as orphans, but that would not be true. They do not mourn the cloud that birthed them, for they are the continuation of its breath. In their heat and light, the nebula's story continues, written across the black pages of space. Each sunrise on every world they will someday warm will be another verse in that unending poem. Even our own sun carries that same legacy. More than 4.5 billion years ago, it formed from the remains of earlier stars, their ashes mixed into a cold, patient cloud. That cloud too once glowed, then faded. And yet, here we are, billions of years later, feeling its warmth on our skin. The light that streams through our atmosphere each morning is the final gift of a nebula that died long before life began. So when we look up at the stars tonight, those tiny, steady lights scattered across the velvet dark, we are not merely observing distant suns. We are witnessing the continuity of memory. Each one burns because a cloud chose to disperse. Each one shines because matter refused to end. The death of a nebula is not a vanishing, but a transformation into something that can last. And perhaps, when we watch the light shimmer through the night, we are seeing the universe's most tender truth, that endings are never absolute, only quieter beginnings. The clouds die, yes, but their children live. They illuminate the darkness not in defiance of loss, but because of it, and in every glimmer, every photon, every silent pulse that reaches us across time, we are reminded that creation never truly stops breathing. There is no true ending in the universe, only continuation, soft and patient like the turning of a great unseen wheel. Every star that lives must also die, but death here is not silence. It is transference. When a star exhales its final breath, it returns everything it has made: carbon, oxygen, nitrogen, iron, the seeds of new worlds. What once burned as light now drifts as dust, cooling in the dark, waiting to be called again into motion. The cosmos does not waste. It remembers, reforms, renews. We have seen this pattern written across every corner of the sky. Supernova remnants like the Crab Nebula, vast shells of color and energy expanding outward through the night. Planetary nebulae, misnamed long ago, glowing like cosmic lanterns around their fading cores. In each the story repeats: creation, transformation, release. The star gives back its essence, scattering the material that once held its fire. Its death becomes the raw material of another beginning, and so the universe breathes. Slowly, endlessly, matter drifts through cycles of warmth and cold, brilliance and silence.
Atoms that once sat deep inside the heart of a massive star may now be floating through interstellar gas, or woven into a planet's crust, or sleeping inside a drop of ocean on some distant world. Nothing vanishes, now it only changes rhythm.
The same hydrogen that once illuminated the first dawn may still glow tonight, reshaped but enduring. Astronomers sometimes describe this as stellar evolution, but the phrase feels too mechanical for what it truly is. It is not only evolution, it is resurrection, repetition, renewal. The universe, in its quiet wisdom, practices a kind of reincarnation. The dust of ancient suns becomes the dust beneath our feet. The light that once warmed another world now fuels the spark of new life somewhere we cannot yet see. And it happens without rush. The cosmos is in no hurry to rebuild itself. Nebulae take millions of years to gather, collapse, and ignite. Stars live for billions more. The process is slow, deliberate, as if the universe understands the art of patience. There is no fear of ending, because ending is only another way of beginning. A star may burn, collapse, explode, or fade, but the elements it creates will find purpose again. Consider iron, the last gift of a dying star. When fusion can no longer sustain it, the star collapses, scattering iron into space. That same iron may someday form the core of a planet, generating magnetic fields to shield new life. The atoms that once belonged to a sun may later shape mountains, blood, machines, and dreams. Within us, within everything that breathes and moves, there is a quiet legacy of stellar death. We are part of the long cycle, participants in an unbroken chain that began billions of years before our names existed. We sometimes think of immortality as something that resists change, a frozen perfection. But the universe teaches a gentler version. Immortality is not permanence.
It is transformation.
The cosmos endures precisely because it allows itself to change form. Stars are born, live, and die. Yet the material of their being continues. It does not cling to its old shape. It accepts the dissolution and finds meaning in becoming something new. Even black holes, the great devourers, participate in this exchange. They consume matter, yes, but over eons they also release energy, Hawking radiation, faint but persistent, returning what they took, piece by piece.
Nothing is hoarded forever.
Even gravity, the universe's most possessive force, must eventually let go. We can see the evidence of the long cycle in every wavelength of light. Radio waves trace the cold hydrogen clouds forming new stars. Infrared reveals the heat of young systems still wrapped in dust. Ultraviolet captures the radiation from newly born suns.
And X-rays, the language of destruction, mark the sites where old stars have died.
Together they form a symphony, or not of chaos, but of continuity. Each phase sustains the next, like breaths in a sleeping giant, and within this pattern we find ourselves. Our bodies are small, brief, but composed of timeless materials. The calcium in our bones, the carbon in our cells, the oxygen we breathe, all are the remnants of stars that once burned and fell silent. We are walking evidence that matter never truly ends. Every heartbeat is a whisper of an older universe remembering itself. When we die, that same matter will return again, to soil, to air, to the next form, waiting quietly in line. The atoms that once carried our thoughts will drift, recombine, and perhaps one day glow again inside the body of another star. In that way, we do not vanish. We redistribute. We rejoin the long conversation that the universe has been having with itself since the first moment of time. There is comfort in that, a sense of belonging that stretches beyond life. The stars do not mourn their endings, and neither should we. To dissolve into the greater whole is not to be lost, but to be remembered in every form that follows. Sometimes, late at night, when the world around us grows still, we might sense that rhythm, the pulse of the long cycle echoing quietly through our own breathing. The universe inhales through creation and exhales through decay. Between the two, it dreams. And though the galaxies will one day fade, and time will stretch beyond our ability to measure, this motion, this quiet transformation, will continue. Not forever perhaps, but long enough to make forever unnecessary. So when we look at a dying star, we are not witnessing loss. We are seeing continuity, a luminous exchange between what was and what will be. Every atom is a traveler. Every light is a memory. Every death, a preparation for new life. And perhaps that is the closest thing to immortality we will ever know. Not the refusal to change, but the willingness to return
again and again as part of the long, patient cycle of creation.
There is a quiet realization that arrives when we look long enough into the dark. The light we see above is not separate from us. It moves through us, lives within us. The calcium in our bones, the iron in our blood, the oxygen that fills our lungs, all were once born in stars. Every heartbeat is a rhythm borrowed from the cosmos, every breath a whisper of some long-vanished nebula. We are not observers of the universe. We are its continuation. Long before there were names or thoughts or eyes to see, the first stars forged the elements that would one day shape our bodies. In their blazing hearts, hydrogen fused into helium, then carbon, nitrogen, oxygen, the alphabet of existence. When those stars died, they scattered their creation into space, where it drifted, cooled, and gathered again into new clouds. From those clouds came our sun, our earth, and eventually us. We are assembled from the debris of those forgotten suns, remnants of fire condensed into memory. Think of that for a moment. The iron flowing through your veins was once at the core of a star. The carbon in your skin burned in stellar furnaces older than our galaxy. The hydrogen in every drop of water you drink has existed since the dawn of time. The molecules of your body are ancient travelers, forged in light, scattered by explosion, gathered by gravity, shaped by time. You are the universe remembering itself, forming a mind capable of wonder, capable of looking back at its own beginnings and whispering, "I am here." And yet, this awareness is delicate. Most of the time, we move through our days forgetting the cosmic ancestry that sustains us. The connection fades beneath the noise of living. Cities, light, motion, thought. But sometimes, in moments of stillness, when the night is clear and silence stretches wide, we feel it again. the faint hum beneath existence, the slow pulse of being part of something immeasurably vast. The dust remembers even when we forget. Science tells us that our galaxy contains more stars than we could count in a lifetime, each one a potential cradle for planets, each planet a possible home for life. Somewhere, countless other beings may look up at their own skies and feel the same wonder, the same quiet recognition, that they, too, are made of the same dust. In that realization, we are connected not only to the universe, but to everything that might ever come to understand it. We often ask what it means to be alive, to think, to feel. But perhaps the deeper question is this: what does it mean for the universe to become aware of itself? For billions of years, matter moved without mind, light shone without witness. Then, through some improbable sequence, consciousness arose, a way for the cosmos to look inward. Through our eyes, the universe finally sees its own reflection. Through our questions, it learns to wonder. It is easy to think of ourselves as small, as fleeting sparks in a vast dark. But smallness is not insignificance. Scale does not define meaning. The cell within your body, though microscopic, contains an entire world of structure and purpose. In the same way, our brief existence holds meaning, not because we are grand, but because we are aware. Awareness is the rarest phenomenon the universe has yet produced, the moment when dust learns to dream. And so, when we speak of nebulae, of fusion and gravity, we are also speaking of ourselves. The same principles that shape galaxies shape our thoughts. The same balance between creation and collapse governs both stars and lives. Within our emotions, joy, loss, curiosity, there is the echo of the universe's own rhythm. Expansion, contraction, transformation. The physics of being and the poetry of being are the same. The stars, in their vast patience, have been practicing this for eons. They burn until they can burn no more, then give their light away freely, without resistance. In that surrender they create possibility. The same is true of us. We live, we learn, we give ourselves to time, and through that giving something continues. Every act of kindness, every idea shared, every question asked. These are our fragments of light, carried forward into futures we will never see. The atoms within us will not remain bound forever. Someday they will drift apart again, returning to the same interstellar medium from which they came. But this is not an ending, it is participation. We are part of a continuum, a circulation of matter and meaning. The universe lends us form for a moment, and we in turn lend it awareness. That exchange is sacred, even if it is temporary. When you look up at the night sky, you are not merely seeing distant suns. You are recognizing family by the ancient lineage of light to which you belong. You are seeing the places where your atoms were once born, and perhaps where they will one day return. The light that touches your eyes tonight may have traveled millions of years to reach you, carrying stories from stars that no longer exist. To see that light is to read a message written across time. Remember what you are, and so we remember. In our science, in our art, in the quiet moments when wonder outweighs fear, we practice remembrance. The nebula within us still glows. The hydrogen still hums. The memory of stars still burns in every living cell. We often speak of the universe as out there, distant and unreachable, but the truth is gentler. The cosmos is not something we observe from afar. It is something we are made of. Its story is written in our chemistry, its rhythm in our hearts. We are not beneath the stars. We are among them. Perhaps that is why we are drawn to look upward, not in search of something beyond, but in recognition of what already lies within. The universe is not asking to be conquered or understood, only to be remembered. And we, its dust made conscious, have the rare privilege of remembering. So when you breathe tonight, imagine the atoms within you, the ancient hydrogen, the starlit carbon, the drifting oxygen, whispering softly, "We have been here before." Imagine them waiting patient and timeless to one day return to the stars. We are not separate from the cosmos. We are its continuation, its question, its reflection. Stars do not simply shine above us. They shine through us. And perhaps in some quiet way, that is the universe's greatest achievement, that it learned to see itself through the eyes of dust and to remember. There is a silence deeper than sound, a quiet that hums beneath every movement of the cosmos. It is the breath that lingers after creation, the pause between one heartbeat of the universe and the next. Every nebula, no matter how radiant, must one day dissolve into that stillness. Its colors fade, its gas thins, its light drifts away into the background glow of eternity. And yet, even in that vanishing, something remains, and a rhythm, a memory, the faint promise of renewal. We began this journey in silence, before the stars awoke, when the universe had only just exhaled its first breath. We drifted through clouds of hydrogen and dust, through the patient gatherings of gravity, through the slow unfolding of warmth and light. We watched matter awaken, burn, scatter, and return. And now as we stand at the far edge of that cycle, we return to the quiet that began it all. Silence is not emptiness. It is potential waiting to be heard. When a nebula fades, it is not dying, it is becoming. Its atoms will scatter through the galaxy, carried by stellar winds, folded into new clouds. Somewhere, light will rise again. The universe does not erase itself. It rewrites. It pauses, breathes, and begins anew. Astronomers have long said that the universe is expanding, cooling, slowing, that its energy is diffusing, its structures loosening, its light stretching into longer, softer waves. One day the last stars will burn out and darkness will return to rule the sky. But even in that distant future, there will still be motion. Quiet, invisible, persistent. The faint glow of decaying atoms, the whisper of gravity's final chords, the memory of what once was. The universe, even as it dims, will still hum with the music of what it has been. If you listen closely enough, perhaps you can feel that hum, not with your ears, but with something older, something in the bones. It is the same hum that guided the first atoms together, the same whisper that taught stars to burn, the same quiet voice that now fills your chest as you breathe. It is the sound of belonging. From the first nebula to the last, everything that exists shares that hum. The stars, the dust, the planets, and us, we are all part of one continuous vibration. The universe exploring itself through endless transformations of matter and thought. When we gaze at the sky, we are not looking outward. We are looking inward toward the deepest reflection of our own origin. The story of the nebula was never just about clouds of gas or physics unfolding. It has always been about connection, how the invisible forces of nature create beauty, how death gives way to life, how silence gives birth to sound. The cosmos mirrors the same truths we live every day, that endings are only transitions, that every release is a form of return. And now, as we stand again in the quiet beyond the light, we begin to understand that this silence is not the absence of creation, but its resting state. It is the breath before the next beginning. Somewhere in the vast dark, another cloud is gathering, invisible and immense, preparing to ignite. Another story will rise, another dawn will come, and another mind will awaken to wonder. The cycle continues. Slow, serene, eternal. When we asked at the beginning, what does the universe dream before it begins to shine? We were really asking what silence holds within it. Now, at the end of our journey, we have the answer, though softly spoken. Silence holds everything. It carries all that was and all that will be, folded into its calm like a promise. And so we listen, not for noise or spectacle, but for the gentle murmur of continuity. Every fading star leaves a trace. Every dying cloud plants the seed of another. The universe breathes in creation, breathes out dissolution, and between the two, in that still point of balance, there is peace. Perhaps that is the ultimate lesson of the cosmos, that stillness is not the opposite of life, but its foundation. The calm between events is not empty, it is fertile. The quiet beyond the light is where everything waits to begin again. We may never see the full circle of this endless story, but we can feel its shape. Every atom that leaves our bodies, every photon that escapes our sun, every whisper of gravity that drifts through space, all become part of the next beginning.
Nothing is lost.
The universe keeps every note, every color, every pulse, and replays them in new forms. And we, small as we are, belong to that continuity. The calcium in our bones, the hydrogen in our breath, the light in our eyes, all are echoes of nebulae that once burned and dissolved into silence. The universe made us to remember itself. Through us, it continues to wonder, to listen, to dream, to everyone who has journeyed through this quiet cosmos with us. Thank you. Thank you for letting science become poetry, for allowing light and silence to meet within your thoughts. We've drifted through the birth of stars, through the slow shaping of worlds, through the long patience of gravity and time. And though we have reached the end of this story, the story itself has no end.
It continues, as in every atom, in every breath.
In every glance at the night sky, if you've felt the calm of the cosmos, if you've found peace in the vastness, we invite you to share where you're listening from. A tiny point of light on this spinning world. To those who have been with us from the first whisper, thank you for being part of Late Night Science. Your quiet presence keeps this journey alive. If this voyage through the stars has brought you a moment of stillness, consider gently liking this episode, subscribing to the channel, and joining us again as we drift through the universe together, softly, patiently, endlessly. And so, as the light fades and silence returns, we end where we began, in stillness. The nebula dissolves, but its memory lingers. The stars rest, but their warmth remains in us. The universe pauses, and in that pause, everything is possible once more. When the stars go quiet, will we still listen? Perhaps that is our purpose, not to command the cosmos, but to hear it. To listen for the next breath, the next beginning, the next whisper of light. The universe exhales, and we breathe with it. The silence deepens and we rest inside it. And in that stillness, calm, infinite, and kind, the cycle prepares to turn again. Good night.